Okay, welcome back. I'm doing this video because I wasn't pretty clear about how the algorithms for storing the matrices work. And today I want to break it down. The coordinate format. So let's assume we have a matrix like this one, 3.1, 0, 4, mm, mm, okay, I wrote all the metrics. The COO algorithm, like data structure, I mean. Oh shit. Okay, I'm sorry. Um, Works like this. I mean, it's very easy to understand. You just store a vector of values that I can call V, and this contains the non-zero values, namely 3.1, 4, 5, 7.4, 2, and 6. And in one vector with tuples or just two vectors, here we store the, the indices of these values. That is, um, 3.1 is located at row 0 and column 2 and so on and so forth. So on and so forth. The other algorithm, the compre column compressed, no, the compressed sparse row format, CSR, works in a slightly different way. We still have a vector with all values, but this time we store we have a vector with the indices of the columns. That is two, 2 because 3.1 is in column 2, then 4, then 2 again because 5 is in the column number 2, and so on. I have to cancel the previous thing because the coordinate system I think was pretty clear. And in the row vector, we compute the how many non-zero elements there are. So the first element is 0 by default. the zeroth position, the element in the zeroth position is 0. Then in the first row, we collect the number of um, non-zero values in the first row, in the first row, that is 2. Then in the second, in position number 2, we have 4 because there are 2 more non-zero values. Then in there's a laser pointer. Oh yes, there is. Wow, cool. Here there are all zero values. Therefore, there aren't more non-zero values, and we keep the 4 also for the next element, and we add 2 more non-zero values, and we get 6 as the last element of our R vector. R vector has, in fact, 4 plus 1 elements because our number of rows is 4. And now, I'm going to implement it on C++, but I think I will pause the streaming because I'm very bad and slow at coding, and in fact, and I'm not even able to cancel this. Okay, thank you for the patience, and we continue. I think that I could stop here the video and then make a final review video when I'm done with everything. We could write together, for example, the make the make file. I mean a bash script to in to what's the name to compile the code to, to compile the code automatically with the required flags that are some warning flags that I have mandatory to use when compiling because it's a requirement of the homework of the task. And here we are, and I think we are done with the theoretical explanation, and we'll see in the next video. Tschüss.